Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss recursive pre-order traversal of a binary tree in Java. So friends, what is a pre-order binary tree traversal? So friends, in order to traverse each and every node of a binary tree, we apply these three steps on each node of a binary tree. So what we do is, we visit that particular node and then we traverse its left subtree and then we traverse its right subtree. So here if you take an example of this tree, then we start with the root node and we apply these three steps on the root node. So what we do, we first traverse this node and then we traverse its complete left subtree and then we traverse its complete right subtree. So once we process this node, we first go to its left subtree and there we encounter a node having data as 2. So on this node we again apply these three steps, that we visit this node and then we visit its left subtree and then we visit its right subtree. So after we process the node having data as 2, we then go to its left subtree and then we encounter a node having data as 4. So we apply these three steps on the node 4. We first visit this node and then we traverse to its left subtree and then to its right subtree. So here you can see node 4 has no left subtree and no right subtree. Therefore we are done with the processing of this node. And then we return back to the node having data as 2. So we have processed this node 2, we have processed the node 4. So now in the third step, we visit the right subtree. So we go to the node 5 and then we apply these three steps on the node 5. We first visit this node, then we visit its left subtree and then we visit its right subtree. So as node 5 is having no left subtree and right subtree, therefore we are done with the processing of the node 5. And once we are done with the node 5, then we are sure that we have processed the right subtree of the node 2. So therefore we have processed 2, then 4 and then we have processed 5. So we are done with the left subtree and then we again go back to the root node 1. And as we have visited the left subtree of that, we now will visit the right subtree for the node 1. So then we go to the right subtree of the node 1 and when we reach to the node 3, we apply these three steps now for the node 3. So first we visit this node and then we visit its left subtree and then we visit its right subtree. So after processing the node 3, we go to 6 and we apply these three steps. We visit this node, we then go to its left subtree and then go to its right subtree. Now as node 6 is having no left subtree and no right subtree, then we are done with the processing of this node. And then we return back to the node 3. So once we return back to the node 3, we have processed its left subtree and now the step remains to process its right subtree. So when we reach to the node 7, we first process this node and then we traverse the left subtree of it and the right subtree of it. So as node 7 has no left subtree and no right subtree, therefore we are done with the processing of the node 7. And then we reach to the node 3. And since we already processed this node, then we reach to the node 1. So friends, in pre-order traversal, we first process the node and then we process its left subtree and then we process its right subtree, and this we do recursively for each and every node. So let's see the demonstration of pre-order binary tree traversal. So friends, suppose we want to traverse a tree whose root is 9 and whose left is a node having data as 2 and its left is having data as 4 and the right of node having data as 2 is null, and the root 9 also has the right subtree having the data as 3 and whose left and right subtrees are both pointing to null. So let's see the demonstration of this algorithm, that how we can process the nodes of a binary tree in pre-order traversal. So here you can see that below is the algorithm for it, and as we are applying this pre-order traversal to each and every node recursively, so here we know that the method name is pre-order, and inside this method we are again calling this method to process the left and the right subtree. So friends, when we are doing a pre-order traversal, we are calling this method recursively, and in order to understand this method recursively, here we are maintaining a call stack which has method call, line number and the root. So in the method call, we'll just keep the track of the method, that which method is being called, and we'll also keep the information of the root, that which current node is being processed, and we'll come to know about line number when we are demonstrating the algorithm. So let's call the pre-order method and we'll pass the root as 9. So when the execution point comes to pre-order, we know that the call stack will now execute this pre-order method, and we are keeping the track of the root. So currently the root is being pointed by the data as 9. So then we check that whether root is equal to null or not. So friends, why we are providing this condition is because this is considered as our base case, and as we are calling this pre-order method recursively, we need a point to exit this recursion, that when root is equal to null, then we simply return from that method. So currently you can see root is pointing to 9 here, so therefore it's not equal to null. So the condition in if block comes out to be false. And then, as we discussed in our previous slide, that first we visit the node, and then we visit its left subtree, and then we visit its right subtree. So we'll first visit the node and we'll print the data associated with that node. So the output is 9. So we have processed this node. Moving ahead. So now we are calling the pre-order method to traverse the left subtree for this root. So the value we are passing to this pre-order is root left. So currently you see root left is pointing to the node having data as 2. And as we are maintaining this call stack, so when we call this pre-order method, we'll keep the track of this line numbers, so that once we return it back, we know that from which line we need to execute the method. So currently from line 6 we are calling this pre-order, therefore we will keep the track of this line number. So here we have stored the number as 6. And now we will again call pre-order method and we'll pass the root.left to it, which is nothing but the node 2. So now root will be the node 2. And here pre-order is again called with a root as node 2. So now we are again executing pre-order with a root as 2. So we'll check whether root is equal to null or not. So currently root is not equal to null. So as we discussed in our previous slide, that once we reach to the left subtree, we process this node, and then we go to its left subtree and then to its right subtree. So now we are processing the node 2. So the output would be 2 because we are just printing the data part of it. Moving ahead. And now we'll again call pre-order method recursively, and then we'll pass root left to it. So currently root is pointing to the node having data as 2, and its left is pointing to the node having data as 4. So as we are calling this pre-order again, we'll keep the track of the line number. So we are placing the line number as 6 because we know that we are leaving this pre-order at line 6 and we are again calling this pre-order. So the point of execution again reaches to pre-order, and this time the root is root's left, so which is 4. So a new root becomes the node having data as 4. And as we are again executing this pre-order, we know that in the call stack this method will be called again, and this time the root is being 4. So we'll again execute this pre-order recursively. We'll first check whether root is equal to null or not. So currently root is pointing to 4, therefore it's not null. And here we'll simply process this node. So the output would be 4. And after we process this node, we know that now we have to traverse its left subtree and then its right subtree. So first we are processing its left subtree. So we are simply calling pre-order again and we are passing root's left. So currently here you can see root left is pointing to null. So therefore we'll now call this pre-order by passing a value null. And as we are leaving this pre-order now here, will keep the track of the line number. So we are calling this pre-order again, and now the route would be null because we are traversing route left. So currently route is pointing to 4 and its left is pointing to null. So therefore our new route becomes null, and there will be one more method on the stack with the name pre-order, and the route would be null. So we'll again execute the pre-order method. So we'll check whether route is equal to null. So currently if you see, route is equal to null. So we have reached our base case. So this base case will help us in exiting the recursion. And as we know that we are left with no more nodes in the left subtree to traverse, therefore we'll simply return from this method. So when we return, this method gets executed. So it gets removed from the call stack. And now, as this method is removed from the call stack, call goes to the pre-order method which was executed just before it. So we'll now start executing this pre-order, and as we know that we have left this pre-order at the line number 6, so we'll now start from the line number 6. And we also know that when we left this pre-order method, at that moment the route was 4. So once the call reaches to this pre-order, route will be pointing to 4. So friends, here we have first traversed the node 4, then we process its left subtree, and now we'll go to its right subtree. So that thing we'll do recursively. So in the line 7, now we'll simply go to its right subtree. So as route is 4 and as right is pointing to null, therefore we'll call pre-order with a null value. And as we are calling this pre-order method with a value as null, we are leaving this pre-order method. So we'll update the line number. That from line number 7, we have again called this pre-order method. So now this pre-order will be called with a value of null. So it's nothing but routes right. So one new route becomes routes right. So now route will be pointing to null. And we also know there will be one more method on the stack with a route value of null. Moving ahead. So we'll check whether route is equal to null or not. So currently route is equal to null. Therefore we'll simply return from this method. So this method gets removed from the call stack, and the execution point goes to the method which called it. So now we'll again start executing this pre-order method from the line number 7. And we also know that we have left this pre-order when the route was pointing to node 4. So we simply traverse to the node 4, and this would become our route. And then we'll start again executing from the line 7. So once we reach the line 8, we know that we are done with the processing of this pre-order method, and whose route is 4. So therefore this method will be removed from the stack, and the execution point will go to a method which called this method. So here the execution reaches the pre-order for the route node 2, and we also know that we have left this pre-order from the line number 6. So we'll start executing from the line number 6. And we also know that when we left this pre-order, at that moment route node was 2. So here the route will now point to the node 2. Moving ahead. And from the line 7, we'll now call the pre-order and we'll pass the routes right, because we are applying this pre-order traversal to each and every node. That we are first traversing the node, then we are processing its left subtree, and then we are processing its right subtree. So as here you can see, we have processed this node 2, and we also processed its left subtree, which is node 4. So now we are left with the processing of the right subtree. So therefore we are again calling this pre-order, and we are passing the value of routes right. So here routes right is null. So therefore we again call this pre-order method and will pass the null value to it. And as we are leaving this pre-order method and we are calling the new pre-order method, so we'll just keep the track of the line number. So it signifies that we are leaving this pre-order from the line number 7. So here now we are calling pre-order with a value as null. So therefore we know that there would be one more method on the call stack whose current route would be null. So therefore now root will point to null, and we'll start executing this pre-order method. So then we'll check whether root is equal to null or not. So currently root is equal to null. Therefore we have reached our base case condition, and we'll simply return from this method. So when we return from this method will be removed from the call stack, and the execution point will now reach to a method which called this method. And as we have reached to this pre-order method, we know that we had left this method from the line number 7. So therefore the execution will start from the line number 7. And we also know that when we left this pre-order method, at that time root was pointing to the node 2. So therefore this root will now point to 2. And then we'll simply start executing this pre-order method. So once we reach the line number 8, so therefore this method will be removed from the stack, and the execution point will reach to a method previous to it. And we also know that we had left this method from the line number 6. Therefore we'll start executing from the line number 6. And we also know that we had left this pre-order method. At that moment root was 9. So therefore now root will reach to 9. So friends, for the root 9, we have processed the left subtree completely. So now it's the time to process the right subtree. So therefore, we start the execution from line number 6. And here we know that we will again call pre-order method, and this time we'll pass roots right, which is the node 3. And as we are leaving this pre-order method, we'll keep the track of the line number. So now pre-order will be called with the root pointing to the node 3. And we also know that there will be now one more method on the stack. So now pre-order will start executing with a root having data as 3. So therefore now root will point to the node having data as 3. Moving ahead, we'll check whether root is equal to null or not. So currently root is not equal to null. So therefore we'll simply process this node, and then we'll start processing its left subtree and the right subtree. So we'll simply print the data for this root node, which is 3. And then we'll process the left subtree of it. So we are again calling this pre-order method, and this time we are passing roots left. So it's nothing but we are passing roots left, which is null. And as we are leaving this pre-order method, we'll keep the track of the line number, which is 6. So now the execution point reaches to pre-order, and this time the root is null. So therefore root will point to null. And we also know that there will be one more method on the call stack, and the root will be null. So we'll execute pre-order with a root as null. So we'll check whether root is equal to null or not. So currently root is equal to null. So we have reached our base case. So we'll simply return from this method. Now as we return from this method, the pre-order method on the call stack with the root as null will be removed from the call stack. And the execution point will reach to a method which had called this method. So we'll again start executing pre-order method. And we know that we had left this pre-order from the line number 6. Therefore the execution point will start from the line number 6. And we also know that when we had left this pre-order method, at that time root was pointing to 3. So now root will point to 3. Moving ahead, from the line 7, we'll now again call roots right, because we had traversed the left subtree for the root 3. Now we'll process its right subtree. So we'll again call pre-order method, and we'll pass roots right, which is null. So when we are leaving this pre-order, we'll keep the track of the line number. So when we call this pre-order method, we had passed roots right, which is null. So therefore for this pre-order, now root will point to null. And we also know that there will be one more method on the call stack with a root as null. So then we'll check whether root is equal to null or not. So currently root is equal to null. Therefore we have reached our base case. So we'll simply return out from this method. So when we return from this method will be removed from the call stack, and the execution point will reach to a method which called this method. So now we will again start executing this pre-order method, and we know that we had left this method from the line number 7. So we'll start from the line number 7, and we also know that when we had left this pre-order method, root was pointing to 3. So therefore root will reach to 3. Moving ahead. Now once we have executed all the statements from this pre-order will be removed from the stack, and the execution point will go to a method which called this method. And the point which we have left this pre-order was at line number 7. So therefore the execution point will start from the line number 7. And we also know that at that moment the root was 9. So therefore now the root will point to the 9. And finally we are done with this pre-order. Therefore this method will be removed from the stack. So friends, in this slide we saw the demonstration of how pre-order traversal works. That it first visits the node and then it recursively calls pre-order to process the left subtree and then to process the right subtree. And this goes on for each and every node. So here you can see the output as 9, 2, 4, 3. So we have visited 9, then we visited 2, then we visited 4, and then we finally visited 3. So friends, here we saw the demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, we discussed how to implement a binary tree in Java. So I had created one class, binary tree, and we have implemented the binary tree in Java. So here we had created an instance variable of type tree node, which was actually root, because this root will hold all the nodes of a binary tree. And we had also discussed how we can create a binary tree by creating the few nodes. Now here let's write a code for pre-order traversal of a binary tree. So public void, we'll give the method name as pre-order. Now this method, as we know, will take in a root which we saw in the slide. And as we are going to call this pre-order method recursively, we'll first provide a base case. So the base case would be if root is equal to null, then simply return from this method. And if root is not equal to null, then simply visit the node. So we'll print root.data. And once the processing of node is done, we will again call pre-order method. And we'll pass root left. And in the last line, we'll again call pre-order method. And we'll pass root.right to it. So here after processing of a node, we are recursively processing the left subtree and the right subtree in a pre-order fashion. So friend, this is the code for pre-ordered binary tree traversal. Now let's test this working in main method. So first we'll create a binary tree which we actually saw in the slide. So here in my previous tutorial I had created few nodes. So I'll just remove one of the node. And I give the data which we saw in the slide as 9, 2, 3 and 4. So we also saw that root was pointing to 9. 9 left was second. And 9 right was holding a node having the data as 3. And we also know that node 2 left pointed to node 4. And we'll just simply remove this line. So here we have created a binary tree which we discussed in the slide, where root is pointing to 9 and whose left is pointing to 2 and whose right is pointing to 3, and then again 2's left is pointing to 4. Now after creating this binary tree, Let's test the working of this pre-order method. So in the main method, we'll first create the instance of binary tree. And then we'll simply call create binary tree. Now once we call this create binary tree, the binary tree will be created and the root will hold the actual binary tree for us. And then we'll simply call pre-order and we'll pass the root of the binary tree. So when I run this code, so here you can see it printed 9243, which we actually discussed in the slide. So friends, in this tutorial we discussed the pre-order binary tree traversal. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.